So we're revisiting scatter diagrams. I don't like their definition, it's too sloppy. A scatter graph shows two things plotted against each other. I don't like the word things, this is mathematics. They're called two variables, two things that can change, and you're observing how one change impacts the other. So if you look at this diagram right here with your books, then you will see that as height increases, shoe size of a person can also change. This probably represents children, I don't know. But if these are all adults, then they'll probably be flatlining because they reach a certain height, they won't get any taller, their shoe sizes won't get any bigger because their feet won't get any bigger. So please understand that height is not a thing, it's a variable because heights change between people. Shoe size is not a thing, it's a variable because shoe sizes can change between people. And here we see a positive correlation, a negative correlation, and no correlation at all. Just to emphasize, the height of a person and their math test scores have no bearing whatsoever. You can be little and get high scores, you can be a big beefy chap and get really low scores. Probably because you're concentrating on your bodybuilding rather than on your maths. So let me start with question 1, exercise 1, page 236. These are the instructions and these are the questions you need to do. You need to do exercise 1, question 1 on page 236. You're supposed to look and show my homework to find that. Also, I need you to copy out that diagram, and that diagram, because if you begin to write about something without a picture, it makes no sense whatsoever. So I know that Hamza, for example, likes to scan these and copy them and then cut them all out and stick them in his book. He's produced many beautiful triangles in the past when we did trigonometry and Pythagoras. It looked really beautiful. So Hamza, if you're up for it, you can scan, copy, cut, stick in your book directly if you want to do that. That goes for anyone else. What you need to do is to literally copy it. You won't get the dots in perfect positions, it doesn't matter, as long as it looks roughly like that. Please note also, everyone, and Brendan's not here, no he's not, can you note that you must explain what the correlation means? It's easy to say that's a negative correlation, but what does it mean? Well, in the context of the question, it means that as the mileage of the used car increases, its value decreases. Yeah, an older car with a bigger mileage on it will decrease in value over time. All right, that's all it's showing. And you need to give English explanation to that using English words. Now, this is mathematics, so I'm not actually marking your English ability at all, but it's got to be stated in a way that's clear enough to get you the marks. So you get a mark for saying the correlation and a mark for giving an explanation. There'll be 6 marks for that one question. Then I've directed you to go into exercise 2 on the following page. So I've just slidden it across here. If there is a correlation that exists between two variables, for example, the science test mark and a maths test mark, then you can validly draw a line of best fit through the data as best you can. As you can see, the correlation isn't very tight. It's not strong, but it's still positive. Generally, students who do well in science tend to do well in maths and vice versa. That's universally true. And just to show you a couple of things that we've come across in year 8, the 2 coordinates that have got a ring around them, there and there, are defined as outliers because they seem to lie outside of the expected data range. So this child did rather well in science but lower than expected in maths. This child did rather poorly in science but did much better than expected in maths. Do you see? Because they're well away from the other piece of data. So that introduces to exercise 2. So now listen to my instructions again. This is a scatter diagram showing BMI, body mass index, and hours spent exercising. Just to say, you do not need to copy that, obviously, because it's an accurate graph from which you are required to read off the line of best fit. So don't copy it. But Hamza, if you want to scan it and stick it in your book, it will look beautiful. What type of correlation is shown in the scatter diagram? Very simple. It goes down. The hours spent exercising increases whilst the BMI decreases. Probably because if you're spending more time exercising, the more mass you're losing. So your body mass index goes down. Yeah, that sounds sensible to me. It's not strictly true, because as you can see, we have two bits of data there, which is an outlier, and there, which is an outlier. And I think they ask you to give the BMI values and the hours spent exercising for the outliers. In other words, that guy spent 1 hour exercising but has a BMI of 21 units. This guy spends about 2.5 hours exercising, something like that, and has a BMI of 25. Both these pieces of data seem outside the normal data range. All right? So that's question 2. And then you turn over the page, and Tyann, just to let you know, you do not need to copy out the table. Why is that? I do bang on about context, but if you plot this data well on this diagram and you label it temperature and glasses of lemonade sold, this graph is telling the story of what's happening there anyway. So that's really got loads of context on it. Okay, so you just plot the silly results, and there'll probably be a positive correlation. As it gets hotter, more lemonade gets sold outside, I'm guessing, I don't know. They want you to draw a line of best fit. You've got to try and squiggle it through the data as best you can. And then there'll be 1 or 2, maybe, any outliers that may be present on the data. It will stick out because it'll be too far away from your line of best fit. And clearly they're expecting a correlation, because it says in part B, draw a line of best fit, and you can't make data fit together if they just don't fit together. Simple as that. So this is what we're about to do when we shut down this lesson. You're going to do this question 1 here on page 236. Copy and answer. Then you're going to move over the page to exercise 2, question 1. Don't copy, but answer. Okay, if you're going to take a scan of that, it will look beautiful. Then you're going to go over to the other page and just do question 2. You don't need to copy that, but you do need to organise a really good scale. Don't do anything as small as that in your book. I know we've got tiny little squares in our book, but if you can like do several squares per unit, it will be fine. It will stretch it out a little bit. It won't be cramped and horrible. Now, I will take questions from all of you right now in terms of what's required cosmetically and mathematically.